Today we're going to be talking about how to use given vectors to draw combinations of those vectors. And in this particular video, we're going to be doing two different problems. In the first one, we've been given these three vectors, u, v, and w. I've labeled them here. And we've been asked to copy these vectors here and use them to find these 6 different combinations of these 3 vectors. In the second problem, we have 2 vectors a and b, which I've labeled, and we've again been asked to find these 6 different combinations of these given vectors. So here's what that's going to look like. Take u, v, and w here. We have 3 vectors. I have an orange, a green, and a blue, let's say. And they want to know what u plus v is going to look like, right? Well, I start with u and I have v here, u plus v. So since I have u plus v, I'm going to take u first. I'm going to start with that. And I'm just going to copy u exactly as it is. So I'm going to say u here like this, and I can label it. And I just want to draw it exactly as I have it up here. And these drawings aren't going to be perfect, but let's pretend I drew exactly the same vector that I had drawn up here for u. So I'm going to start with u, then I want to add to that v. Well, when I draw v, what I want to do is I want to take the initial point of v and I want to put it at the terminal point of u. So let's get our definitions right here. This is the initial point of the vector, the point where the vector starts. This is the terminal point of the vector, the point where the vector ends. So what I want to do is take the initial point of v, which is this point right here, and attach it to the terminal point of u and start v there. And then I just want to copy v. So let's pretend that v looks something like this. V should look exactly like our original copy of v here. So that's u and v. What we know from vector addition and the triangle law is that the vector u plus v, the combination of u plus v, is going to be this third vector here that connects the initial point of our first vector u and the terminal point of our last vector v. So we're going to start from the very beginning of where we started and go to the very end of where we finished, and this is going to be u plus v, like this. So that's how we draw u plus v. That's what the vector u plus v is going to look like. Same thing here with u plus w. So we start with u. We're going to draw u in here like this. Let's pretend that looks exactly the same as our original u. Then we're going to attach w to it, and w looks about like this. Again, attaching that to the terminal point of u. We're going to say that that's w. So then that means that our vector u plus w starts at the very beginning of where we started, ends at the very end where we finished there, and that's u plus w. If we do v plus w, we're going to start with v. So we're going to start with v, and we're going to draw a copy of v like this. We're going to attach w to the place where we left off there. W looks about like this, so that's w. So what that tells us is that v plus w is this vector here, v plus w, that connects the very beginning to the very end. U minus v, again, we'll start with u, so we start with u here. We'll call this u. And then we subtract v. Well, notice that up until this point, we've always done addition. Now we're dealing with subtraction. If we were going to draw positive v, what we would do is just copy this original vector v exactly. But because we have this negative v, what we're going to do is draw something in the opposite direction. So negative v is the vector that goes in exactly the opposite direction and is the same length as this original vector v. We call this negative v right here. So they have the same magnitude, they're just in the exact opposite direction from one another. So putting in negative v, attaching that, negative v is going to look about like this. We'll say negative v. So what that tells us is that u minus v is this vector here from our very starting point to our very ending point. This is u minus v. So that's how we deal with a negative vector like that. Now v plus u plus w, we'll start with v and we'll do this. We'll say here's positive v. We add to that positive u, so that's going to be about like this, positive u. Add to that positive w. That's going to look about like this, positive w, something like that. So then we say that our vector v plus u plus w is the very beginning point to our very ending point. This is v plus u plus w here. Now u minus w minus v, we should be starting to get the hang of it at this point. We're going to say u like this. Now minus w, let's do that in a similar color here. Negative w, again, exact opposite direction, but same magnitude. So maybe about like this will be negative w. So let's go ahead and draw negative w like this, negative w. And then we have negative v. Well, remember we already drew negative v. We know what that looks like there. So a negative v is maybe going to be about like this, negative v. So then we know that our vector from our very beginning point to our very end point, we have to be a little careful here because we're going to draw over it, it looks like. But our vector u minus w minus v is this vector here, u minus w minus v, from our very beginning point to our very end point. Let's do another quick example with some slightly different applications here. Just because these two vectors are attached to one another, just because they have the same initial point, doesn't mean anything. They might as well have drawn them separately. We just need to follow the same process that we did earlier, where we attach the initial point of our second vector to the terminal point of our first vector. So here we have a plus b. We start with a, so we'll go ahead and draw a here, like this, a, and then we have plus b. So we attach the initial point to the terminal point, and we say that b looks about like this. So a plus b is going to be this vector here, a plus b. Now a minus b, same thing here. We'll start with a, like this. We'll draw a vector a. Now negative b or minus b is going to be the same vector, but in the opposite direction, like this. So negative b, we'll go ahead and draw negative b like this, negative b. So then a minus b is this vector here, a minus b. 1/2 a, now this starts to get a little interesting here. It's the vector a, but half of the magnitude. So same direction, but half of the magnitude. So 1/2 a is going to be half like this, 1/2 a. So we just need to draw this vector here and call it 1/2 a, like that. That's all there is to it. Negative 3b will be the same as negative b, because we have this negative b here, so the same as negative b, except a magnitude of 3 times negative b. So if we imagine 3 times negative b, it would just be 3 times the length of this negative b here, so it would look, let's say, about like this, something like this. We'll call this negative 3b. That's 3 times negative b, because we have about negative b here, here, and here, so 3 times that length. Then a plus 2b, again, we just got a regular a, so we'll start with regular a like this, a here, then plus 2b. So 2b again here is going to be b except double the magnitude, so this would be about what 2b would look like here. So we're just going to draw 2b about like this, and then our a plus 2b vector is our beginning point to our end point here. This is going to be, this white one here is a plus 2b. And then finally 2b minus a, we start with that positive 2b, so we're going to go about in this direction right here. We'll call this 2b. Then minus a, again, it's just the same magnitude as our original a, but in the opposite direction. So minus a is going to look about like this here, minus a. So minus a here we attach to the terminal point of 2b, we get minus a. So then our vector called 2b minus a looks like this from our original initial point to our final end point. That's 2b minus a right there. So that's how you can use pictures of these given vectors to quickly and easily find combinations of those vectors.